acceleration. And after that, evaluate the movement in the various speed. At the same time, its payload capacity. So it's up to you what is your task or result that you want to know, so that you will also check the evaluation criteria, your criteria of evaluation on your research. Then lastly, during the testing, you will learn a lot of things that, let's say for the body, it needs to be deducted with the weight, so you can refine your prototype. So for the literary review, there are only 3 things. One is, what are the climbing robots application? Then second, the adhesion mechanism, and then the locomotion mechanism. For the application, it could be in the walls, high buildings, storage tanks, shipyards, and again, the current trends in Taiwan, that is the wind turbine installation. And there is a problem, certain physical problem that they are now facing. And second is the different types of adhesion, so that your robot will stick, it will not fall to the ground, because automatically there is a gravitational force. It will always fall to the ground. So your adhesion mechanism will adhere, it will stay on the tower. That need to know the different adhesion mechanism. Then the third is your locomotion, either in leg or in a wheel type, or a rope, or a track base. So there are different types of wheel that you are going to study, and even the mecanum type of wheel. And lastly, what will be the final application, a specific task that your robot will do, either painting, cleaning, welding, repairing, material handling, object manipulation, inspection, diagnosis, and maintenance. Now, as I have mentioned to you, these are the developments of locomotion mechanism. So these are the types, either leg type, a track-based type, hybrid. There is also hybrid that you mix the wheel type and then the leg, or cable-driven. Then for the adhesion mechanism, we have magnetic type, gripping rope, thrust force, vacuum suction, or even the dry or electrostatic type of adhesion. Now, reading all those literary, so maybe you have to read 50 to 100 related studies, but mind you, you have to pick the best 5 very related to your study, and then focus on those 5 researches. Again, I study all the locomotion, and these are the pros and the cons of the locomotion type. And then I pick the wheel drive, considering its positive or the pros of this locomotion. It is a fast movement, efficient, low cost-effective design, optimal flat surface performance, high payload ratio, and of course terrain and obstacle traversal is quite not needed in my research. But still, it is a pros attractions, magnetic type of adhesion. But on the gripping rope, it's only few. And then, what are the pros and the cons? Surface adaptability, reliable adhesion, surface compatibility, easy attachment and detachment, lightweight, mechanical requirements, alignment precision, surface limitation, and grip viability. Then, of course, we studied all the different types of wind turbines that is installed in the wind farms, and the very common or a lot of wind turbines that are Vestas V80, that is 2.0 megawatt turbines. And it is being ratio. We have to scale down the prototype so that if we are going to do in the future study for Taiwan to have a bigger one of climbing robot, then the aspect ratio is 1:10. And of course, the material is steel. Now, for the climbing robot model, we have this two body framework that is on this part. We have the adhesion, where our adhesion mechanism is situated or located, and on the other side is where our controller, where our programming is being done in microcontroller. Then we have these different parts. We have the power supply, the twin pulley, and the step motor, which is considered 1 and 2, is the adhesion part of the adhesion mechanism of the study. And then we have the Bowden cable, microcontroller on the other side, then other electronic modules such as distance sensor, relays, and motors, wheels, and caster wheel. The caster wheel that is on the in the lowermost part is the one that will help the robot to stand or to firm its stability, in terms of stability of your robot. Then, of course, we come up with studying all the forces behind those robots. You have to do the mathematical analysis of certain force, tension force, frictional force, and then the gravitational force. And of course, for the body frame 1 and then for the body frame 2, you have to consider the weight. What will be the weight of your robots? And then consider what is the maximum payload capacity. If I'm going to add a camera, how much is the weight that can withstand in terms of your payload capacity? Then, of course, the driving wheel analysis, in which there is the inclination of your in your tower. Then, of course, your torque of your wheel, and also there is an angle inclination of your normal force that is equal to the inclination of your tower. And then for the alpha, because your wheels are being like it is a curve shape, it is not a linear type. So there is also a angle that is being calculated, and that is our alpha for the every wheel has its own alpha, or the angle of inclination of your wheel. Then this is for the wheel is we have this processes or flow chart. So it will start with the initialization. Once you turn on your prototype, tiny robot, you have to input the speed. So the speed either low, medium, and fast. And then after that, it will use or measure the distance between the ground. Your distance sensor will do checking what is the distance from the ground, because your robot, if your robot is on the lower part of the tower, it will just automatically goes up. But if your robot is at the top part, then he will determine through the distance of the ground that he needs to go down. So this will be the process flow. Once your distance sensor is lesser or greater than 80, then it will stop and input direction, either it goes up and goes down. It will just automatically goes up and goes down. That is considered part of your programming. And if your robot is on the lowermost part and able to sense that it is below 80 millimeters, then it will go tighten the adhesion mechanism, and then the motor will run, then going up and measure the distance of the ground. And then there is a connection. You can have a manual stop even if it reached to the middle part, or if there are certain condition like wind gust, then your robot will able to stop, and then you can manually stop and then end the process. And then the other part, it will goes down. Once your robot is on the top part of your tower, then able to recognize it is go beyond 1,200 then it will loosen its cable, the adhesion part. And then the motor will go run and going downwards. And again, you can do manual stop. And then certain wind condition like wind gust or any problem of the robot, then you can end the process. If there is no interruption, then it will just going downwards and then end of their process. Now this is the design and then the actual prototype, the top view, and then we have the body frame of each part, frame 1, then the body frame 2, and then the movement of the wheel. As it goes upwards, it will goes in of your tower, but as it goes downward, it will goes out. So clockwise or counterclockwise of your wheel. Then we have this testing, and then the result of the testing. So in this result, there is a low speed, medium speed, and then the high speed. And then for the low speed, it is 20 seconds, and the result is 62 milliseconds, meters per second, that it goes as it reached to 1,200 and then the data shows as a linear going up. And then for the medium speed, it will reach 16 seconds going up, and then 8 seconds going up for the fast speed. Then we have also, sorry for the perpetuated, then 2.92 kg is on the body frame 2. The maximum payload capacity is 3.5, in which you have this body weight, and then you can add 1.5 and 1.5, total of almost 3.5 kg in each body frame. And then the speed, we have the 50 mm second, 62.5 millimeters per second, and 125 millimeters per second. So for the RPM, we have 45 to 75 RPM in each wheel. And then for the medium, we have 44 to 66 RPM. And then for the high, we have 44 to 77 RPM. So the winding RPM is around 19 to 25 RPM. And then we have the angle inclination, that is 1.67 degree. And then the total tower height is 1,200 mm. And then the diameter of your lowermost part is 400. And then the uppermost part, diameter of your tower is 333 mm. Now, in conclusion, the development of wind turbine tower climbing robot has been successfully tested through indoor experiment of the prototype with the wind turbine tower, marking up and proving the viability of the design. So, second, based on the friction created by the Bowden cable, using a cable, then the 4 rubber wheels, the robot can climb straight up and down movement with its various speed. And the significant advantage of the design was the winding mechanism that can withstand the cable tension force to contract the tower surface, and the high payload capacity to install additional equipment to its approximately above 50% from the robot's total weight. That is around 3.5 kg. So you can add more weight on the robot. And finally, the results indicate effectiveness of driving and winding mechanism to climb with and without payload. Now, for the recommendations, I think it will have the movement going sideways, considering we have to study more on the mecanum type of wheel, which is another type of wheel that is can move sideways. And the application, either you can do painting or washing, but as to the project that we have, we will just add camera so that we will check what are the defects or the corrosion of the body of the tower in the project that we have. And then lastly, this is just about our program, that in our electromechanical technology, we have these academic researches and extension. Like this one, we have Lambigit. It's like going together, share inputs that we have through research, and next month we will have Lambigit, and maybe some of you in next year we can collaborate. What are the top 5 researches in engineering and technology programs that you have, and then you can have it online. So in the different programs that we have, I think we have 5 colleges, and each colleges around 5 to 6 or 7 programs, departments. So maybe in these 5 there are 40 to 45 contenders or participants who join this Lambigit, and then collect the best researches in the different colleges. So we have this yearly, and next month we are celebrating the Lambigit in our university. And maybe next year I will invite research of our students, undergrad students on the design and development of 6-axis robotic arm with computer vision in the modular production system. These are pick and place. There is a certain camera, and then let's say pick those workpiece that are metal, so picking from one place to another, moving from another station of a MPS modular production system. Then we also have this innovative transformation of mechatronics, a gear loading station, and advancing efficient and integration. So it will just go up and then move a certain workpiece. And then this workpiece is moved to the next station. So these are the different researches that our student is doing. It's mostly on the PLC programming, and then on the different types of sensors. Then we also have this mechatronic sorting of the different workpiece, either brass, metal, or steel. So these are the works of our students. And then because of the new, there is a, I think that's not new, but the current trends in the industry is on the variable frequency drive. So we have this type of prototype wherein we are going to put a certain workpiece, and then it will just move faster as it goes to the end. And then as it reaches to the end, then the movement of the conveyor will go slow. And then this one, I joined in the Indonesian second time of Indonesian competition of a research design, and we won 4th place of this research innovation that our student is doing. And we were able to receive around, it's 6,000 pesos, so maybe 12,000 rupees or 10 to 12 rupees. And maybe next year I will also include you, one of our, tell our Indonesian friend that you can join on the online competitions of your best researches on its design. Then we have also this research, design and implementation of a multi-stage automated product processing system. So these researches is not just mere on the mind of the student. It's actually the real problem of the industry. Our student went to the industry, and then they will ask staff or technical people, what are the existing problem that you are facing in your industry that we may address to do it in our research. It means that our research is not looking for a problem, because there are so many problems that we are going to, even looking for a problem, you cannot find a problem. So the best way is go immerse yourself in the community. What are the suitable problem that they are facing or to the industry, because our course is aligned to the industry. So we let our students go to the industry and look for a problem. And even this one, this pineapple sorting is also a big problem in the industry, because once the pineapple plantation is taking all the pineapple fruit, it will just put on the truck without counting, because they will just base on the tons. Like it's already 2,000 tons in a certain truck. So there is no counting of the pineapples. So the Del Monte, Philippines, give a certain problem that our student address. able to count the pineapples and then go back to industry and then tell the industry that we were able to do it on our research. And sometimes we receive fundings from the industry, certain industry. So this one is kind of porridge industry that is still installing its machine and then giving all the problems that these are the problems that we have, and then maybe you can try have it simulation on in your university. So these are the actual parts, the putting the porridge in the tank. And then this one is weighing scale, weighing and segregating of the prototype of the porridge. And then this one is a lot code and monitoring of a machine vision wherein through the scanning of camera, this is the batch of a certain product, and then putting a date of expiration. And yes, and also we as a faculty members, we do research. It's a must, should do requirement of the university that every year you present internationally or locally your research that you are doing. And we are also having a social responsibility through the new curriculum of a junior and senior high school. So we are, as a university, we are connected with the industry. At the same time, we are also connected with the high school, that is the Department of Education students or faculties, so that whatever inputs that we have is matched to the courses that we are offering. And that is, and our graduates will be matched to the industry that we are producing. So in our course, only few graduates will have unemployed, but most of the graduates that we have are being employed in a high reputable industry. It's because this is the current and the present call of the industry, wherein you have to know the PLC programming, the automation part, the calibration, and even the mechatronic parts. And this one is one of our activity. This is doing our part to the high school and high school teachers in our region, that there will be a training on the mobile robotics, and we are the one who train those teachers and able to come up with the competition regionally. So this is one of the extension programs that we have, and maybe you can have an insight as one of the criteria for requirement that we must do. We have to do professional growth. You need to study, do master's and doctorate degree. Then you have to do extension program, research, and your teaching. So these are the 4 criteria that you need to do as a faculty members of a certain state university. So this one is an extension program of our university, and we also immerse ourselves to the industry. Immersion. There is a faculty immersion. We may stay 1 to 2 weeks in the industry so that we are able to learn what are the new machines that are being installed in the industry, what are the current sensors that they are using, and then implement to our university so that our graduates are able to understand the language of the industry and match what is the current trends in the industry. Then we also have Nestle and then other Sleers company. Now, to sum it up, I want to leave this challenge to all of you, to the students, faculty members, researchers, and other dignitaries, that where are we right now? We are stepping on the traditional, or we are embracing modern or the current trends of engineering. Are we a type of a problem finder and solver? Are we combine technical skills with soft skills? And lastly, are we the type of a person that we thrives on the international relations and opportunities? Again, I see a lot of stars right now, but I will leave it that as you see those stars on the skies, only few are shining brightly. And it's up to you if you will shine bright or you will just remain not so like typical type of person that will show all your potentials. I believe Indians has the highest potential. Explore what are your potential and making the best of your skills. So thank you so much. Shukriya for listening my presentation.
With that, we conclude Dr. Kathleen ma'am presentation. Please join me in giving a big round of applause. Thank you ma'am for your insightful presentation on the topic named as Engineering a Scaled Down Prototype of a Vertical Climbing Robot for Wind Turbine Maintenance. We now open the floor for questions and answers. I request all the participants to ask the questions without any hesitation.
Yes. Yes, good afternoon. Feruj, I think I need your help, Dr. Feruj. Because of the dialect, I need yes. It's okay, thank you. Prototype. Okay, how I manage to climb. So first thing, again, there are two most important things that you should learn. The adhesion and then the locomotion. So, for the adhesion, I use the Bowden cable. On the body frame side, wait a moment, I'll show you. This one. Okay. This part, the left side, there is a the distance is being sensed by a sensor, the distance sensor, then it will automatically tighten or loosen to go up or to go down. Yes, I hope I was able to answer your question. Yes, Professor.
Hello. Yes, it's a very nice presentation. Thank you for that. And you have been done very deep research about the whatever the prototype that you have been developed. May I take your permission to suggest two things and ask one thing? I want to suggest two things
Yes,
and I want to ask one thing.
all right.
First, two suggestions. You have not discussed about the power capacity and power efficiency that is required. So how much watts of energy that you are supposed to consume, that climbing robot is to be consumed per kg of the payload and its own weight.
Changing again, pardon.
The power, electrical
Yes.
power that is required, watts of electrical power per kg of load.
Load. Yes.
So that point is not been discussed. So how much is efficient,
All right.
power efficient?
No, in the load part, in the power part, we only have 24 capacity voltage, 24 power voltage capacity, and then for the second one is the efficiency.
The power capacity, watts per kg of load. That is efficiency.
Yes, as to the each wheel has a 12 volts capacity, total of 24 volts capacity. Each power body frame. So the body frame of the prototype able to withstand the total parts of 24 volts DC capacity. DC.
That is fine, but the efficiency part. So how much it is power efficient?
As to the efficiency, Professor, I'm only on the RPM in each wheel that I take data. So it's in my presentation. Wait for a while. Only on this data that I have. Wait. It's around 45 to 74 RPM of the each wheel for the low speed, and then for the medium speed it's around 44 to 66 RPM on its efficiency, and then for the high or the fast speed it's just around 44 to 77.
Yes. The second suggestion is you have not discussed anything about the soft start and soft stop, because you are going opposite to the gravitational force and you are coming with the gravitational force down. So there must be some soft start and soft stop mechanism over there, otherwise braking the speed may damage the robot sometimes.
Yes, one of the problem that we are facing is on the caster wheel. On this part. Wait a moment. The lowermost part. Here. In the Professor, the caster wheel, you know, that is the braking part. That's during the testing. That is the one of the problems that we are facing, as you have mentioned. But again, as it goes up and goes down, there is a sensor that will check the distance. Time to time,
question.
Yes.
Actually, it should not be asked at this particular stage of your research. Have you ever thought about the robot with the help of drone?
Drone. We come up with the idea, but one of the reasons of taking this climbing robot is that like cleaning. If you want to clean on the offshore, and then the drone must take some, like a hose for example, then you are doing in the offshore part, so it's difficult, it's a difficult process to do. But if this type of climbing robot, you will just attach and then detach, and then it will just go up and then making a certain specific task.
Okay, thank you very much. Very nice job. Thank you.
Professor, I hope I satisfy all your questions.
Yes.
Yes, Professor. Like I'm on the hot seat right now. There's no other person.
Hello, madam.
Hi, Professor.
It is very insightful information you have given on the climbing robot. But I have a question related with sir. In design, I have not seen the inertia on the robot, because the robot is climbing up. What about the inertia force, which is opposite to the motion of that robot? That I think while designing that is not considered. And second one is how you can incorporate AI with this climbing robot.
All right. So for the AI, artificial intelligence, like we are going to mimic the human thing, right? When you say AI, it will able to do ability to mimic a certain person like us, human can do. So monitoring or checking using a camera, that is a real-time monitoring the defects and assess either it is just a corrosion or it is just a, let's say, let's say corrosion or paint peel off. So maybe we can use that one, or grease or oil grease problem of the wind tower. So I think sensing and real-time monitoring is one of the application, so that the data that is being captured of the camera will automatically send via phone probably, or through the monitoring, SCADA monitoring, or any monitoring device, and then address the issue and fix the problem directly to have a corrective maintenance. Professor? Okay, thank you. You can have me personally if you have more questions. There is no problem with me. And then even if you want to have collaboration with research, I am more into industrial PLC automation. If your research is on that side, then I can help you and even do some international research presentation and win for a prize. I think I can help you out on that. So thank you so much for your time. I hope you learned something and you will able to see what are the trends that our institution is doing. It's not automatically shifting full automation, but slowly and slowly we can have like a one step at a time to have a better research in the future and become a better researchers in the future. That's what we are doing. So, but in the advanced countries like Taiwan, it's totally different. Materials, the devices, everything is really given to you.
Yeah, thank you very much, Kathleen ma'am. I request you to take a seat in front.
Take a seat.
Yeah, take a seat.
Okay, thank you.
Thank you very much. We pay our sincere gratitude towards Dr. Kathleen Padrigalan for sharing her expertise and knowledge on the topic that is the critical issue in the energy sector of the wind turbine, maintenance of the wind turbine and the help of the climbing robot. Really, it was a very knowledgeable session, and I hope the participants have gained more information and more knowledge on this topic. Once again, very much thankful to you, ma'am. I request, as we are ending with our inauguration ceremony as well as the plenary session first, which is delivered by the Dr. Kathleen. So just give me for a while. I am here to put a vote of thanks of the two sessions. So on behalf of Dattakala Shikshan Sanstha and Dattakala group of institutions, we pay our sincere gratitude towards Dr. D.S. Chauhan, Dr. R. Ashwani, Mr. Rajendra Gangarde sir, was today's chief guest for honoring their presence and sharing their inspiring thoughts with all of us. Also, we extend our heartfelt gratitude towards our keynote speakers, Dr. Kathleen, Dr. Mycel, Dr. Dviputra, Dr. Firoj for joining us today and gracing the inaugural session of this conference with their presence. We would like to acknowledge the constant guidance and support of our Honorable President Sir, Professor Ramdas Zol Sir, and Honorable Secretary Madam, Mrs. Maya Zol Madam, for their constant support and inspiration. Also, we pay our gratitude towards our directors, principals, all our HODs, and our colleagues for their continuous support and guidance for conducting this conference. Last but not least, I would like to pay gratitude towards all participants, both offline and online, for their enthusiasm and presence, which has made this session truly memorable. We look forward to engaging sessions, meaningful discussions, and fruitful collaborations in the sessions to follow. So with this, I declare this inaugural ceremony and plenary session first is ended over. So as we have started a little bit late, so I request all the participants, we are going to start our next plenary session second, which will be delivered by Dr. Dviputra, Associate Professor from the Indonesia University of Negri Padang. So I request all the participants and all the dignitaries, our next plenary session will start at 2:30 p.m. So I request all to be present here at 2:30